My name is Sumit. I'm in a business unit at IBM called IBM Systems, and I run the product offerings around AI and machine learning. Been at IBM for about 3 years. Before that, I used to be the general manager for AI and data center at NVIDIA. I was there for 8 years. I built that business unit at NVIDIA. So many years of experience in this space, particularly around deep learning. So first of all, I know you all realize it's important because you're spending a day here. But I always show this slide to emphasize the importance of this space. It doesn't matter whose numbers you look at. The numbers have zeros and billions in them in terms of the market opportunity in this space. So, you'll hear people say AI is the new electricity, AI is the new fire, AI is the new water. It's all of the above, right? I tell people it's the new Java, C, C++. It's going to be everywhere, right? Every programmer in the world is going to use AI. Right? And more people will get into technology because of AI, right? So there's going to be some sound around the doom scenario, jobs are going to go away. The flip side of this is many, many new jobs are going to get created. It's as big a revolution as the greenhouse revolution or the industrial revolution, right? It is fundamentally a very impactful technology. And by the way, we all are consumers of AI today. Every one of you is consuming AI. Whether you checked the weather this morning, or you used Google Maps to route you here, or you use Apple Siri or Google Voice or Alexa, every one of you is using these technologies that are out here, right? The interesting thing for those of you who want to build a business around this is the opportunity in software services also pretty big. Right, that's another very interesting thing that comes out of it. And I'm building a business around all of these things, so I'm trying to go after $30 billion. That's my target market opportunity. Let's start with I'm sure a lot of people talk to you about what AI is. I like to start with this because people ask me what's the difference between machine learning and just programming, and the difference is that in programming, it's an if-then-else. It's very procedural, right? So if you want to recognize a bicycle and you want to teach a computer how to recognize a bicycle, classical programming would say that if has two wheels and a handle and pedals, is bicycle, right? Now, that's pretty easy to go recognize this image. Gets a little harder here. You can't see two wheels anymore. If you're really smart, you can see the handlebar. Almost impossible to teach a procedural computer program to recognize these as bicycles, right? I mean, some of us will have a hard time recognizing the toilet bicycle there. So, but that's what computer vision, or that's what we are able to process, right? And now, how do you do this, right? It's perceptive learning. It's how do you teach a baby to recognize a dog? You show them lots of pictures of dogs, dog. You say, there's a dog. And one day the baby sees a dog and says, dog. The baby is not thinking if has 4 legs and has tail wagging and no. It's not thinking like that. Baby is perceiving a dog. It's perceiving certain features in the right place and saying this is a dog. Now, if you haven't shown that baby a cat, the first time the baby sees a cat, he or she will say dog, because the baby has learned animal. The baby has not really learned dog. The baby's learned that there is things that are different from humans, and those things are all dogs. Right? Therefore, we show babies cats, horses, and in India we show them elephants, snakes, and monkeys. Right? So, that was supposed to be a joke. Come on, wake up, guys. I know we just had lunch, and it was pasta, and pasta is heavy, and you feel slow, but that was a joke. So, but the point is, all of these things are all animals. We're also able to categorize at a high level that these are all animals, right? So we're able to understand abstract concepts as well. So that's the challenge that AI enables, right? That's the problem we've solved. Why in the last 12 to 18 months is there this craziness about AI and computer and machine learning and deep learning? Because we've solved this problem. We've finally solved this problem after 60 years of computer vision research, and I'll tell you why. So at the highest, so the other thing I want to disambiguate is my title. I have VP of AI and machine learning. The reason I have AI is because business guys know that. The reason I have machine learning is because my actual target audience knows what that is, right? So let me disambiguate what these two terms are. At the highest level, all AI means is we're teaching a computer to mimic humans, right? The most general purpose computer will be able, at one day we'll have this general purpose or generalized artificial intelligence, which you won't be able to discern is a computer. We can almost do this today with call centers. You can almost do this today, that you can have a pretty good discussion with either a chatbot or even a human sounding voice and not realize you talked to a computer. We're getting that good. But you ask it, hey, so did you watch the game yesterday? Dead, right? Unless it's been programmed to answer that question. So, but it can answer, let's say, technical questions and so on. Machine learning, as I explained with the example of the bicycle, is instead of learning in a programmatic way, you learn from experience, right? So instead of saying if then else, in other words, rule-based approaches, you don't use rule-based approaches, you use approaches where you're showing the program lots of data points of a similar thing. You're showing it lots of dogs. And eventually the computer program not only tells you it's a dog, it starts teasing out the species, the type of dog, right? Similar, I see this with, I have girls, but I see this with young boys, where boys can tell apart cars. Like, that's a car with a V8 and blah, blah, blah. And so how did they do that? Experience, right? They read a lot, but they also saw a lot of pictures of cars in magazines, online, whatever it is. So machine learning learns from experience. The term deep learning is a particular method within machine learning that is, let's say been rejuvenated in the last few years, that is just really, really good at some tasks. And the difference between machine learning or, it's a subset, but the value that deep learning brings in, it learns, it's very accurate with a lot of data. And it uses a method called neural networks. So that's as technical as I'll get. Neural networks is the most technical word I'll use today. But, I heard there was a professor who spoke in the morning, so I'm sure you saw a lot of equations and math behind this, right? So I won't go down that path. But let me explain at a high level what the difference between machine learning and deep learning is. Machine learning is an relatively old technology. I want to say 50 years old. And what machine learning used to do is, if you wanted to recognize staplers, you had a human, usually a PhD in computer science, a PhD in computer vision, who would say, what the most important things when you're recognizing images is edges. Then they would say contrast is important, right? Dark contrast, light. So you would have someone figuring out what are the most important features. This is called feature engineering, feature extraction. Once you knew what the most important features were, then you would use one of the machine learning algorithms to classify, right? Classification means putting things into buckets, right? Well, this thing looks like this bucket, this other thing looks like, these are edges, these are contrasts, and so on. And eventually your bucket is able to recognize a stapler, right? Your classification is able to do that. So there's many reasons deep learning is interesting. One very big benefit, in my opinion, of deep learning is that the deep learning network, the neural network, figures out the most important features. We feed it a lot of data. It starts figuring out what the most important features are. So I dropped the slide for lack of time, but for example, if you feed a neural network model 100,000 faces, just don't tell them what it is, just faces, just a face, nothing else, just lots of faces. Eventually, the neural network layers, the first few layers start figuring out edges are important, right? I see edges again and again, and it seems like an important feature. Then a little later, another layer starts figuring out, I see this pattern again and again, and it's an eye. It doesn't know it's an eye, but it just knows I'm seeing this same thing again and again, or noses, or mouths, or ears, right? It starts detecting meta features. Eventually, it figures out the latest layers, the last layers start figuring out that usually eyes are laid out like this, a nose is here, and a mouth is here, right? So we didn't tell it there's something called an eye. We didn't even tell it what a face is. We just gave it a face, right? Or 100,000 faces, or a million faces. It figured out that these things are important. These things show up again and again. So you'll see online, you'll see some, in fact, there was a recent work where they were showing that they took an image and they started deleting some things from the image. They took an eye out. And then the deep learning model regenerated an eye. Now, the eye that it generated didn't look like the other eye, but it was very similar. So it was smart enough to sort of look at the other eye and say, well, this eye is probably going to be similar. Then they deleted both eyes in the image, and it regenerated 2 new eyes. Now, in other words, it knew where to put the eye, the fact that usually eyes exist there. Now, the eyes that it generated didn't look like the original person's eyes, obviously, because it didn't know that, right? We'd just given it a deleted image. But the point, it knew eyes are important, and here's the placement of an eye on a face, right? Okay, we can go interactive.
This is very good. Where did you put in the word training here? Training is the first on machine learning or
Yeah, so everything I'm going to talk to you about today is going to be about training. So that's a very good thing. So let me explain what he asked. The question was, when are you going to talk about training versus inference? So when you teach an AI model that this is a dog, when you're teaching it, that's called training. Once you have a trained AI model, now you just give it a new image and it recognizes that that was a dog. That's called inference or classification, right? So training is when you're teaching the AI model. That is done offline. It may take months to do. Inference is what, when I talk to my phone is inferring or understanding my words. But that AI model that's running on my phone plus the cloud is actually been trained over months and years in Google or Apple or Alexa, wherever, Amazon. So that's the So everything I'm talking about today is training.
Oh, so deep learning also has a concept of training?
Yes, absolutely. So deep learning, all of this stuff, when I say you give it a million images of faces, you're training the AI, the deep learning model. Because remember, this model, when you start with, knows nothing. It's like a baby's brain that has never seen anything in its life. Right? Now, there are methods called transfer learning where you take models that have been taught something. So, for example, Google had a very famous paper around this where they taught their AI model how to translate English to, I forget, I'll say Spanish, right? Once it learned how to recognize English and understand English, they then changed the back end, just the back end, to now also generate French, now also generate German. So that was sort of a transfer learning example where they had a brain that knew how to understand English, understand the semantics, all of that stuff. Then they just had to teach to how to speak other languages, right? In other words, how to generate other languages. So that's transfer learning. Now, the excitement around AI, this chart captures the excitement around AI. This is the number of searches on the term deep learning. I bet you if I publish the same chart for the number of papers that New York Times or Wall Street Journal has written on AI, it looks something like this, right? In other words, they used to write a few in the past, and in the last 12, 18 months, they've gone crazy, right? Every week there's a New York Times. Every 2 days there's a New York Times article on AI, right? Because we're clicking on it, we're reading it. The reason is it's deep learning, right? So the method that revolutionized AI, revolutionized machine learning is deep learning. And the reason for that was exactly what this chart shows. Deep learning very significantly improves the accuracy of our AI models, right? And the best example of this is here. We had 50, 60 years of PhDs in computer vision, maybe 10,000 people. I don't know how many people have got a PhD in computer vision, right? After those 50 or 60 years, these experts were able to get to 26%, 74% accuracy in computer vision. And the problems that we used to have is, for example, if I had a Starbucks cup here and I held this, as a human, I can see the edges, and because of my brand recognition on Starbucks, recognize it's a Starbucks cup. At least I can tell you it's a coffee cup. And that ambiguity, right, of seeing something, and like if I look like this, I can barely make out all the heads, so I can't count anymore. Computers used to fall over on those kind of things, where there was a lot of overlap, it was hard to see. So the error rate was high. Humans have an error rate of 5%, roughly, right? So we can tell these situations pretty well. The revolution happened here. This was the first deep learning revolution, right? with deep learning, in 2016, we started beating humans at vision, at speech, so both speech recognition and natural language processing, right? And this is the reason why this whole craze and why we are all sitting in an AI bootcamp at TiE 2018, and there was no AI bootcamp at TiE 2017, right? That's precisely what happened. Is some major leap forward, and this is why the whole world is AI is the new electricity, blah blah blah. The term AI and machine learning are 50 years old, right? But this is really what has happened. We've actually had a step improvement in our capabilities. Now, for some of you here who will object to my overselling on deep learning, I put this chart in for you all's satisfaction. I'm not saying machine learning is dead by any means. Deep learning, for all the hype, is still a very small percentage of the methods that real data scientists use. So this is a Kaggle survey. It shows you that the most is all online. You can take a picture of me pointing to it, but you can find it online too. Tweet the picture though. It'll be fun if you tweet it. Logistic regression, which is a very, very simple method in machine learning, still kills it. It is just a beautiful method, very simple to use. So if any of you are planning to use machine learning in your company or in your work, try logistic regression. It's like the gold standard, right? Once you have logistic regression working, you'll get so much insights. Then try all the tough stuff, if it can beat it, because this stuff is also hard to do. This is almost like a chart of how hard it gets to use methods, right? It's almost that kind of a chart. But deep learning is becoming very valuable for some things. So I want to show you a few demos. Like I used actually one of our own APIs to do this. This is just an API we have online where you can throw pictures and it'll tell you it recognizes actually any kind of image you throw on it. This one is any image, this one is faces. So in this case, it's not only recognizing it's a vehicle, it's telling you colors. The interesting thing I saw here was the probability that it's a convertible is 54%. And the reason for that is if you look at that image, you can't quite tell if it has a black top or not, right? Now, we could potentially train this better with similar images. This is actually a good example where if we wanted to raise the accuracy of this particular type of image, we could just give it 10,000 images that are like this and tell it this is a convertible, this is a convertible, and then it would be able to start discerning these kind of scenarios. Now, this is another interesting one where we're able to not only tell whether the person is a male or a female, but also their age band, right? It lies about me. I am still 25. It gets my age wrong every time. Another joke, wake up people. Thank you for laughing. But this is pretty useful, right? I mean, so imagine if you're a retailer. Every retailer these days, if you go to Safeway or something, they actually have a camera looking at you, if you've ever seen this at checkout. And the camera is there for surveillance. However, you could use this standard API and start figuring out that, hey, every morning from 9 a.m. to 10 a.m., there's women between 35 to 45. They're coming in. You can now check the point of sale. That person, what did they buy? So you don't know, you don't have to know who they are. You just need to know, female 35 to 45. Usually, this is the kind of things they're buying. Right, and if you have, let's say, a Starbucks in the store, then you can also say that around the same time these women also bought Starbucks. Now you can start putting promotions out. At 9 a.m. you could put stand up something that upsells. I'm sorry, I'm picking on women here, but men or kids. I mean, the best example is kids. I go to this coffee shop, Starbucks, and after 3, it's full of the high schoolers, and I always think these guys are idiots. They should put a sign up at 3 p.m. that upsells these kids to the, whatever caramel latte or whatever they buy, right? And except for my kids. Everyone else's kids should buy, they should upsell them. But that's the opportunity, right? To use the cameras that exist already. You're collecting the data already. You're doing it for another reason, which is surveillance. So all the infrastructure has been paid for. Right? I was a retailer, a local retailer, actually a small retailer here, and his big problem is, he was telling me, is that since California banned plastic bags, people come in with their own bags, and people shop and put it in their own bag. And then people figured out, hey, I don't have to actually take out everything at checkout. So they take out if they have 6 bottles of wine, they take out 4 and scan them and keep 2 in the bag. So they experience an increase in theft because people are using their own bags. So, and he said, I can't have people watching surveillance cameras, right? I mean, the statistic on surveillance cameras is that after 20 minutes of watching a surveillance camera, most humans' error rate is around 50%. In other words, we're just distracted. We're playing a Candy Crush on our phone while watching a surveillance camera. So how do you automate this? Well, we can put a camera in his wine aisle because that's his high-ticket item and figure out how many bottles were removed. And at least in the first instance, tell him within half an hour how many were removed versus how many were at checkout. Right. So now he has he can tell, okay, between 9 a.m. to 9:30, 12 were removed, but only 4 were bought. He can go back, look at the video. It pinpoints for him. Now, the next thing we can go do for him is we can actually now start tracking people. If you removed a bottle of wine, we'll track you through the rest of the store. Right. Not too hard to do, by the way. I know it sounds creepy, but it's going to happen, whether you like it or not. Right. And that's the kind of stuff that can really improve retail analytics. And if it sounded creepy, by the way, Amazon is doing this to you today, right? So get creeped out next time you're on Amazon.com. They're tracking you, Google's tracking you, Facebook's tracking you. Everyone's tracking you through everything. The reason Google produces Chrome is to track you, is my opinion. Sorry if I offended my Google friends here. I'm probably never going to get a job at Google now. So the other example I like to give here, and I'll pause after this slide to take questions, is this food example. So we built this honestly, someone built it for fun, but we built this where we could recognize different food items. I paused on this one because I find it really interesting that it can recognize that that's kale. The picture isn't that high res, but it also has this other probabilities here. It thinks it could be broccoli rabe, which is 50% probability. And you can throw many different things: sushi, English muffin, open sandwich, naan, lamb chops, scampi. Now, let's go back to my retail example. I do self-checkout a lot, except when I have groceries. Because in groceries, you have to punch in the number, you have to look it up and stuff, right? Again, same retailer. Produce, right. I'm sorry, that's what I meant to say. Produce, right? If you have cabbage and stuff or carrots and stuff, you have to put in the number, you have to look it up. So it turns out the same retailer I was talking to said that the error rates on that for his human cashiers is pretty high as well. I mean, high meaning 10, 20%, or the time lost in someone trying to figure out, hey, what's the damn number? Because they memorize the numbers, by the way. It's actually industry standard numbers, right? And they'll punch in non-organic instead of organic. So they have all kinds of issues. You could use this kind of a food recognizer and get pretty good accuracy on these checkouts, right? And you save a lot in terms of also human time, right? Punching in numbers, right? These guys, the checkout people, that's usually the pain point of most stores, right? The checkout line becomes big during a busy time, and then lots of people are picking up produce, and it becomes an issue. So you can now start combining this. I mean, I showed images, now I'm going to video, right? Now you can start combining this and start doing some pretty interesting stuff like tracking players. My next one will do the next one, but tracking players through it, right? So now the reason why this is important is we get to watch all the big games on TV, but many of us are college football or college game enthusiasts, but you don't get to see those games. You don't get to see highlights from them. You don't get to get commentary on them because it's too expensive to produce. But it turns out you can actually put cameras on most college, and the cameras exist on most college fields, right? You can start automatically getting a lot of this material with highlights, right? So you could start doing things like generating where the players are, all the video clips around it, pretty much automatically, right? I mean, to double click on this idea, I'll come back to that slide. I want to show you this idea first. We actually have been working with a lot of the golf tournaments, the Golf Masters, the US Open, and others, to automatically create highlights of the game, right? And here, instead of just images, we're actually Reading means we're reading what the stats are, right? Is it a game point? Is it an 18th hole? What have been the stats of this player? We're listening to the audience, we're listening to the player, and then we're watching. In particular, player actions tell you a lot. You'll watch in the middle, he'll go like this. That's a very key player action, right? The player's excited, or the player in tennis throws their racket away. You can teach the AI model that these are important things. So let's watch the video.
And after so many years, once and for all for Sergio.
So it's watching that he was excited. The audience is clapping. It can hear the audience clapping. It can see the audience's hands are up in the air, right? All of this stuff. So excitement level. It ranks every clip. Now, the reason why that excitement level was low, it turns out, is that the commentator was weak. But if you watch golf is like that. I mean, the golf commentators, that was an excited golf commentator, by the way. So that's as good as it gets. But you can now see we're going sort of what's known as multimodal AI or multimodal training, right? You're not just watching, you're listening, you know other things about the scene, you know like in tennis, you can teach it game points, match points, you can teach it that, once you're in deuces, the advantage points are usually more exciting. So there's a lot of things you can sort of metadata you can give it on importance. So again, back to my example, right, on how you use this. If you are a college and you have alumni who still enjoys watching the games, but who's going to watch a football game at a college for how many people will go invest that much time? But I want to watch the highlights. Well, we can generate those automatically, right? It takes minutes for these highlights to be generated. The reason why the big sports guys are interested in this is, for example, the US Open, in the first few days of the game, you have 50 games happening at any one in a day. And creating the highlights of 50 games, each game requires 2 to 4 people. It takes 4 to 5 hours after the game is over to create the highlights, production, stitching it all together. We do it in minutes. As soon as the game's over, you have a highlight. Right. So, and again, there's so many other use cases. We've been talking to a lot of esports companies, a lot of gaming companies to create highlights for esports. Watching other people play games online has become another sport watching thing. I know most of us in this room are too old to appreciate that. Maybe I'm talking about myself, but my kids love it. They love to watch other people playing games. So creating highlights for that. So this whole automatic creating highlights is an important thing. I'm going to try to see if I can make this video play. Okay. So the reason why I like this video is what you're going to see is what you saw this morning and you're going to see again is a computer learning how to play a game itself. Now the reason why this is very, very important is the only thing that this computer was told is you can go left or right, and you get rewarded if you break all the bricks, or you die, you lose a life. Those are the only inputs it has, right? Here's what you can do, and here is a reward or a penalty. It doesn't know that it's playing a game. It doesn't know what the game is or the objective of the game or any of that stuff, right? And the other thing is the reward and the penalty is very far away. It's not like if you move right now, you will die. You move right now and you may die because you moved too many times right and the ball went to the left, right? So the delay between reward and or penalty and action is very high. Now, if you saw the game, right, eventually this thing not only figures out that how to play the game, it figures out the key strategy of the game is to actually build a tunnel on one side, get the ball in the back, and start smashing it, which is very advanced, by the way. I played this game when I'm 25 now, so a few years ago. It took a long time to learn this. So this was the point I was trying to make, right? So all you have is an action you can take, and you get a reward or a penalty, right? Many times it's just a reward, and there's a new state. There's just, again, I lied. There's a second mathematical thing on my slides today because it has a little mathematical term. The thing here is that you're optimizing for a very late reward. So, for example, if I'm picking stocks, right? If I just watch the stock movement right after I buy or sell, some people do that, but most people are trying to optimize for long term. So I can't tell myself, the reward for my automatic program can't be that the stock go up in the next 5 seconds. It has to be, did the stock go up in a time frame that I define, which is 6 months maybe, right? So how do you correlate your action today with 6 months later? That's where these kind of reinforcement learning systems come in. Typically, people are using simulators for this. So the game in that case was the simulator, but people are doing robotics with this. It's very hard to teach a robot to actually grab things and place them in certain places. Now, actually making a robot do that again and again is also hard. So people have built a simulator that simulates if you grab, and they have a deep learning model running, which is learning from whether that what it did was right or wrong. It's a little hard to explain. I hope I'm getting some of it across. The game one actually people are using to build game adversaries. When you play a game, right, the gaming company wants you to keep playing as long as you can. That's they call it engagement, right? So when you play a game and you just beat the opponent but not quite, you feel like playing again. So what they do is they make a better opponent based on your skills. So they see how well you're playing, and then the opponent's skill actually improves, and you don't realize it, right? And they just keep you engaged, right, to keep you playing the game again and again and again. And there's lots of other things, right? You can build optimal treatment policies, right? Doctors do this, right? Often you'll find doctors with more experience are able to prescribe a treatment that a less experienced doctor would not have thought of. They would have gone to an easy conclusion. The experienced doctor just has, I've seen people like you walk in and I gave them this, and then 6 months later this is what happened, versus I tried some other treatment. So they're able to sort of, in the back of their mind, they have a deep learning neural network working that is actually doing this very long training that sees long outcomes. So how do you teach that to an AI model? So this is a very important method. It's hard to explain, but I thought I'd make sure you guys understand reinforcement learning is important. If you're doing something real in your work, you should do it. I am actually running out of time, so what I'll do is, instead of presenting more slides, I'm going to end at these two. One more slide because, but I want to tell you a few use cases for the enterprise. By the way, so mostly I sell to enterprise, right? That's who I call on. I don't do consumer services. Most of the examples I gave you were consumer because they're easy to understand. But in most cases, right, these are the kind of things my clients are doing. And we have pretty broad client base, right? I mean, this is the summary chart, which is all these other clients types that we have. And then let's do this. Someone asked, I was asked to talk a little bit about Watson, so I'll show you one slide on Watson. The way to think about Watson is, the primary thing that Watson brings you is a set of pre-trained AI models that are good at some things, right? So Watson has a very good vision API. So if you want to, like I showed you the examples, they were all running on Watson's vision API, right? So you can use our pre-trained models. You want to add a voice search to your app, we have speech APIs. We can recognize tone. So when people call into your call center, we can tell you, we can flag people who are getting angry, flag people who are happy. So we can tell their tone. We can tell we can do a lot of personality insights given some of the data about them. There's a whole bunch of stuff around chatbots, documents. We're very focused on PDF document, semantic search, and correlation. So the medical field in particular, the correlation is, I read a paper which had 20 references, which now have 20 references. So how do you, correlate if you're looking for a particular drug's interactions? How do you go find all the information about it? And that's a semantic search, not a direct search. So Watson enables that. The other product, which is my personal product, this is the product I manage, is based on open source software. And this is for companies that are building their own in-house machine learning software or training models, right? What we do is we take the open source software, TensorFlow, Torch, whatever you like, and we provide an enterprise distribution. So think of it this way, just like Red Hat packages Linux, you don't go to linux.org, right? We believe that most of our enterprise clients don't like going to tensorflow.org. They want an enterprise distribution, right? Like Hortonworks or Cloudera packages Hadoop, we package TensorFlow and other frameworks. And then we enhance them. We enhance them for ease of use. We enhance them for performance. It ships with a server. So we roll in an AI platform for a client and it just works. The data scientist doesn't have to worry about how many servers, what cluster management, all that stuff. It's all hidden away, right? All the data scientist has to worry about is Python and TensorFlow. And then the last slide, we've also popped it up a level. We've built a software that automatically builds an AI model for images and video. So it's literally a 1, 2, 3 here. You choose a data set, you click build model, and you can deploy. And you can deploy either in your browser or we have embedded deployment strategies as well. So here is an example where in the GUI you can mark, let's say, cars, pedestrians, cross sections, and essentially label the data. And then you can click on train. It automatically picks the deep learning model, picks the hyperparameters, tunes them, builds a model. I'm going to stop because I'm way over now. So I hope this last minute talk was valuable to you all. So thank you for listening. Thanks.